All right, hello everyone. I'm Serafino Morpagados. Welcome to Embry Riddle Prescott campus if you haven't been here before. Some of you haven't. Today we're going to be talking about the projects that we've been working on for the past 4 months. And these are the ground robot you see over here to my left and the quadcopter to my right. It's a cooperative control, which means they're working together. So we're going to start off with the ground robot team, so let them introduce themselves.
Hello, my name is Michael Brown.
My name is Inigo Nicolas, and we're both part of the ground robot team.
Robotics is a major part of mechanical engineering, and as two aerospace engineers, this is one of the reasons why we chose this project, because we wanted to get an experience in a different field outside of our own aerospace engineering. The robot was given to Dr. Gill from the Commonwealth Police Department in the hopes of building a stronger relationship between the police and the university. The main goal and purpose of this project is to restructure and fix the robot and ultimately give it back to serve the police department.
When we received the robot, it had multiple problems with them. One of the problems were the cameras. The robot has 2 cameras. One is located in the front, the other one is with the taser gun. The front camera has night vision capability. The other one, the good thing about it is that you can go into places, look around 360 degrees, and you can aim and shoot the taser gun at someone while you look at them. You have the exact same vision as the taser gun. The problem with the cameras is that the wire was not done properly. It's like connecting a DVD player to a TV. The wire was not done properly, so we did not get an image at all. Now we can say after we fixed it, after we took the entire system apart, we can say that we can see 2 different images, flipping the switch of the remote control on the screen between the night vision camera and the other camera. The other problem with the robot, another problem with the robot was the hitch. The hitch was not working at all. For some reason, we just pretty much took the entire hitch system and rewired and the entire thing, and now it works. And what it basically is a solenoid, and then when you charge it, pushes up a little metal piece, and when you discharge it, it releases it. So now we can actually tell a lot of things like the car we built. We'll talk about it later.
Another setback that the robot faced were the track systems falling off. When making sharp turns, the tracks would sometimes fall off, leaving the robot paralyzed. This isn't very ideal in a police situation. To fix this problem, we took a look at the connections between the wheels and the motors. Now there are 2 main motors on the robot, located diagonally from each other. We took apart the wheels and the motors and reconnected them and retimed them, making the tracks more taut and preventing them from slipping off. Another setback that the robot faced was the battery life. We tested battery life using 2 different test conditions. The first test condition was run full power with cameras on. This resulted in a battery life of about 1.5 hours. The second test condition was run full power, cameras on, and the light bulb on. And this resulted in the robot actually overheating after about 45 minutes. We took a look at the light, and this was the main reason why the robot overheated. The light was a halogen light bulb, and replacing this halogen light with 2 LED lights, our robot did no longer overheat, and the battery life was about 1 hour and 15 minutes long. The very first day that we actually got the robot, we tested the range to be about 50 to 60 yards, and this doesn't present a good enough safety cushion between the police and the criminal that they're pursuing. To fix this problem, we took a look at the communication between the antenna and the receiver on the robot, and we noticed that a new antenna connector needed to be purchased. We soldered the wire from the receiver to the new antenna connector and connected the antenna, and received a range of about 220 yards now. In summary, these are the improvements that we've done with the robot. We got both cameras working out, and we're able to flip between the main camera on the taser gun and the front camera for night vision capabilities. The hitch is able to carry big loads. As you can see, we're carrying an aerial vehicle right now, and it can also carry supplies such as a first aid kit or something else to hostages in hostage situations. The tracks no longer fall off, and this lets the robot move freely. The battery life, the robot does not turn off anymore or overheat due to 2 new LED lights mounted on the front of the robot, as you can see. And the range was increased from 50 yards to 220 yards, giving the robot a great safety cushion between criminal and police.
Another improvement that we made to the robot, when we got it, it had a little cart on the back that was able to carry supplies and stuff like that. But what we wanted to do is incorporate the aerial team into our project. And so in communication with them, what we did is we built a bigger wagon that would be able to carry their quadcopters as well as carrying any type of supplies. Now this is the final design of the wagon we built. We have multiple other designs. One of them was actually getting the box and putting it on top of the robot, but we thought it was going to be not visually appealing because the box is actually pretty good, big, and the robot is not that big. So another option was building a structure around the quadcopter, giving a circular ends at the for the robot, for the rotors to turn. But it was going to be too hard to build, and so we just went with the easy option, I guess. And this is the final version of it. It's made out of plexiglass, and it's connected with aluminum corders.
We will now be showing a short video highlighting how the robot can overcome different obstacles and terrains that are presented to it.
As you can see, it can go through rocks without any problem. It can go up and down the stairs.
Now, this is the very first day that we actually tested the robot on the stairs, so we're a little bit nervous that it would tip over and break. So that's why it's going so slow here. But after a while, we became confident, and as you can see on the way up, here in a second, the robot performed very well and did it very fast.
So you can see it can go over anything in any terrain, basically.
And with this, we would like to introduce the aerial robotics team.
Good afternoon, I'm Michael Rosnick.
And I'm Serafino Borbatos. And we're the aerial robot team. This is just a quick overview of what we're going to talk about today. We're going to go over our goals, the capabilities, the missions that we want to accomplish, and the testing that we've already done.
So the first of our goals was for the quadcopter to be capable of fully autonomous flight, both indoors and outdoors. Now, the means we use to primarily accomplish this will be an ArduPilot 2.5 open source module. This computer module keeps track of things such as the quadcopter's altitude, its heading, and everything you need for flight.
With that same computer, we actually have some sensors hooked up to it that are going to allow us to do some obstacle avoidance. There's 4 infrared range sensors located on the bottom. You can actually see on the silver box there, those 4 black things on the bottom, the infrared sensors. We can get a distance pretty accurate with those, and the onboard flight computer will calculate which direction for it to go.
One of the other things you can see on the top of the quadcopter is a camera. Well, built into the camera, we're going to add object recognition to the system. Object recognition will allow us to do things such as extremely precise operations where we need to follow a specific target or land in a really confined area.
Another general goal for our whole project was we wanted the platform to be very flexible. We wanted to accomplish a variety of missions and have parts interchangeable so it can be changed out to do those other missions very quickly.
And here's a list of some potential missions we thought the quadcopter would be excellent for. The first one here is a first aid mission. In the wake of a disaster such as a terrorist attack or an earthquake, the quadcopter could be fitted to carry first aid kits and fly a search pattern. As it finds victims, it could drop them a first aid kit and relay their location to first responders so that they could get the treatment they need more quickly, and the first aid kit can hold them over until the responders get there.
Another idea we had would be to send this thing into nuclear reactors where it's very dangerous to send a person in. And it can actually go and find any leaks in the reactor by itself using its object recognition. It can go places even a human can't go to do that as well.
One of the other possibilities we thought that Quad could be used for was a tactical recon vehicle for soldiers in the battlefield. As you can see, it's fairly small and could be carried by an individual soldier. Well, in the case that a squad is pinned down by enemy fire and they can't tell where the fire is coming from, perhaps from a concealed target, they could send up the quad and utilize its object recognition to find the hard-to-find targets, such as a sniper, and then, equipped with a laser designator, it could mark the target for an airstrike.
Using these same patterns, you can actually set it out to fly a designated route beforehand. You can actually change it on the fly as well. We'll talk about that a little bit later in our testing. But using that search and rescue, we'll be able to use it very effectively. It can find someone who's lost or stranded and actually get supplies to them very quickly and relay the position of that person to the search and rescue personnel so they can be rescued faster.
One of the other possibilities would be for the quad to be used for aerial surveillance of an area, and possibly for hot zones such as the U.S. Embassy that was recently attacked in Libya. When a place is in danger or a specific zone, such as if criminals recently escaped, the quadcopter could keep watch over the area and record any unusual activity and alert authorities to respond quicker. So here's some of the testing we've done. So far we've tested the payload, which currently comes out to about 1.5 kilograms, but we're getting a new battery for it. With this new battery, we expect the payload capacity to at least double.
We've also done some waypoint navigation. We've actually flown the quad around campus by itself. It's really neat to see this thing fly by itself. It's kind of an eerie feeling not being in control of this thing as it flies around. And you can actually set waypoints on the fly as it is flying around. It can land within about 3 feet of where we designated to as well.
And one of the other goals we've accomplished has been flying the quadcopter with the carbon shell you can see right here. We've flown it a couple times with the original version, and you'll see this one fly a little later on today.
We've also done the very initial phases of the obstacle avoidance testing. We're still working on it, still working out the kinks, but we expect to have that working in about a month. I'd just like to show you a quick video of an autonomous flight. You can actually see it taking off here. This is all by itself. All you do is flick a switch and it goes. It got up to its cruise altitude here of about 60 meters. And we're actually going to land right about there. And now it's using its onboard sonar sensor to detect its altitude so it can land softly when it's towards the ground. It actually took us some time to get to it because it was so far away. So you'll see us walking up here. We had to cut because it was so long. And now I'd like to introduce Truman for his exoskeleton.